Chapter 2. Hunter-gatherers of the Paleolithic and Mesolithic Ages. Chapter Outline. The Geological Ages in Hominid. Evolution. Hominid remains in the Indian subcontinent. Paleo-environments. Classifying the Indian Stone Age. The Paleolithic Age. The Mesolithic Age. Conclusions. In the summer of 1863, Robert Bruce Foote, an officer of the Geological Survey of India, was busy with his routine survey duties at Polavram near Madras, modern Chennai. A stone embedded in a gravel pit caught his eye and he picked it up. It was a seemingly unremarkable piece of brownish quartzite, with one end chipped off, but Foote recognized the unmistakable signs of human workmanship in its form. He had found a hand axe, the RST Paleolithic tool discovered in India. Foote went on to ND and study many more stone tools and made major contributions to research on Indian prehistory. The Polavram Hand Axe was not the RST prehistoric tool discovered in India. In 1856, L.E. Mesurier, a railway engineer, had found a small chert arrowhead near Nilgiri village in central India. Prehistoric tools were subsequently reported from many areas including the eastern Vindhyas, the Jabalpur area, Sindh, the Andaman Islands, and Bengal. The geologists who played a major role in these discoveries shared their evidence and ideas with European geologists such as Charles Lyell and archaeologists such as J.D. Evans. In 1868, Foote traveled to England to inform the scholarly community about his work, and in 1873, some of the prehistoric tools he had discovered in India were displayed at the international exhibition held at Vienna. Within 2 decades, the foundations of Indian prehistory had been laid and had received international recognition. Since the 19th century, hundreds of prehistoric sites have been identified in the Indian subcontinent and new methodologies and perspectives have enhanced our understanding of the Stone Age, the longest part of the human past. The sources of information include structural remains, burials, plant remains, bones of humans and animals, and rock art. However, the most prolific and important sources are the tools, mostly of stone, made and used by prehistoric humans. The craft skills represented by these tools must have been developed through experimentation over centuries and carefully transmitted from one generation to the next. It took time, strength, labor, skill, and patience to make stone tools. Some of them are so aesthetically fashioned that they look like works of art. Stone tools are found in different contexts. They may occur on the surface of the ground as surface NDS, embedded in river deposits at habitation sites, or at factory sites, places where tools were made. It is important to know whether the artifacts were found in a primary context, in the place where they were made or used, semi-primary, slightly removed from their original place, or secondary context, far removed from their original position. There are various ways in which prehistorians try to ascertain how stone tools may have been made and what they were used for. They can experiment and try to make similar tools, or they can study communities who make and use stone tools today. Another method of understanding the functions of stone tools is microware analysis. In the course of its frequent use, as a tool comes into repeated, regular contact with certain kinds of materials, its surface and edges develop wear marks in a polish or gloss. Different kinds of activities, cutting plants, chopping meat, cutting hides, etc., leave different kinds of wear marks and polish. By carefully examining these under a powerful microscope, it is possible to make inferences about what the tool was used for. The question of who made the tools is more difficult to answer. However, considering the active involvement of men and women in subsistence activities, it is very likely that both sexes participated in making stone tools. Stone tools were a very important part of the lives of Stone Age humans and are therefore an important key to understanding their world. But prehistory is not only Mesolithic paintings, Kathasha, Ramkaja, Bhimbatka, after Neumayer, 1983. About describing and classifying stone tools. It is about using these and other remains to try to discover the life ways of prehistoric people. The geological ages in hominid evolution. Humans like to think that they have always been the center of the universe, but science has proved that this is not so. This planet and its innumerable species are part of an amazingly long, complex, and continuing drama of evolution, in which human beings made a very late entry, and have so far played a very minor role. The Earth is about 4.5 billion years old and humans appeared on it only some 200,000 years ago. The many advances in the physical sciences in the 20th century have greatly amplified our understanding of the Earth's history, while genetic science has unveiled the complex mechanisms that underlay the biological evolution of species. In recent years, advances in DNA analysis have provided important evidence regarding the process of human evolution. The foundations of geological and biological evolutionary theories were laid in the 19th century. Charles Robert Darwin's path-breaking book, The Origin of Species, 1859, explained how new species arose due to adaptation and how the process of natural selection led to the survival of the fittest. Darwin had been deeply influenced by Charles Lyell's Principles of Geology, 1830-33, which explained the past changes in the Earth's surface as results of still continuing processes such as wind action, erosion, earthquakes, and volcanic eruptions. Thomas Henry Huxley's Evidence as to Man's Place in Nature, 1863, extended Darwin's idea of evolution to human beings. The authoritative writings of such scholars ultimately revolutionized prevailing ideas about how and when human beings appeared on the Earth. Evolutionary theory had enormous and unsettling implications, and it is not surprising that many 19th-century Europeans found it difficult to accept. It ran counter to the biblical theory of creation, according to which nature and humans were created in all their perfection by a divine agency according to a divine plan. It was not easy to accept the idea that reptiles and insects had appeared on the Earth long before human beings, or to recognize certain similarities between humans and chimpanzees, or to think of the world as millions of years old. Just as disconcerting was the fact that evolutionary theory suggested that change in nature was continuing, unpredictable, and unstoppable. The breakthroughs in the natural sciences had an immediate and major impact on prehistoric archaeology. Stone tools had been found and reported in earlier decades, but a theoretical perspective within which such NDS could be understood was absent. For instance, in 1836, a French customs officer named Jacques Boucher de Perthes had discovered int tools in the Somme Valley. He had argued that such tools, in some instances found along with bones of extinct animals, were remains of humans who had lived long before the biblical Old. De Perthes' work was greeted by general skepticism until his NDS were authenticated many years later by the geologists Hugh Falconer and Joseph Prestwich, and the archaeologist John Evans. Today, geologists divide the history of the Earth into 4 eras or ages related to the evolution of life forms: primary, Paleozoic, secondary, Mesozoic, tertiary, and quaternary. The tertiary and quaternary together form the Cenozoic, or the age of the mammals, which began about 100 million years ago, Maya. The Cenozoic is divided into 7 epochs, of which the last 2, the Pleistocene and Holocene, are especially important for the story of hominid evolution. The Pleistocene began about 1.6 Maya, and the Holocene, or recent period, in which we live, about 10,000 years ago. In biology, evolution refers to the gradual changes in the heritable features of a SPE-size population over successive generations due to changes in gene frequencies and the process of natural selection, which favors traits that help the species in adapting to the environment. Over time, this process can give rise to a new species. The terms species, or species, and genus are central to discussions of evolution. A species includes organisms that are similar in physical structure and behavior and which interbreed with each other, or which could do so if they had access to each other. A genus is an assemblage of related species. Take the following example: Canis familiaris, the domesticated dog, Canis lupus, wolf, and Canis aureus, jackal, all belong to the same genus Canis, which is mentioned RST. The second word is the name of the species they represent. There are many differences in skin color, facial features, hair color, body build, height, etc. among modern human beings living in different parts of the world, but we all belong to the same species of anatomically modern humans, Homo sapiens sapiens. The second sapiens refers to our subspecies. Homo sapiens is a Latin term, meaning thinking man. Paleoanthropologists have used fossil evidence to piece together the fascinating story of the biological and cultural evolution of early humans. This is not an easy task. It is sometimes difficult to identify a species on the basis of incomplete skeletal material, and it is not always clear whether these remains are representative of the entire population of an area. Nevertheless, Different stages in the process of human evolution can be identified, as can the implications of crucial biological markers such as increase in cranial capacity, brain size, changes in pelvic structure and the beginnings of bipedalism, walking erect on two legs, and the modification of dental structure due to changing food habits. Some important aspects of the cultural evolution of early humans include the making of stone tools, the emergence of some kind of social organization, the beginnings of language, and the capacity for symbolic thought. The earliest known hominids, man-like species, were members of the Australopithecus genus, who lived roughly between 4.4 and 1.8 Maya, and their remains have so far only been identified in Africa. The earliest of these, Ardipithecus, or Australopithecus ramidus, seems to have evolved from some common ancestor of the hominid and pongid ape. Lines in sub-Saharan Africa about 4.4 Maya. While the Australopithecines may have used naturally available material as tools, there is no conclusive evidence that they were tool makers. Fossil evidence of the earliest representatives of the genus Homo habilis, hand-using man, was found at sites such as Kubifora in Kenya and the Old Ave Gorge in Tanzania, and is dated about 2 Maya. The earliest stone tools have been found at Hadar in Ethiopia and have been dated about 2.5 Maya. Homo erectus, named for his/her fully erect posture, appeared in East Africa around 1.7 Maya. From here, this species seems to have spread to various parts of Africa, Asia, and Europe. The RST Homo sapiens appeared a little less than 500,000 years ago. From about 130,000 years ago, there is evidence of Homo sapiens neanderthalis, Neanderthals, in various parts of Western and Central Asia and in Europe. Whether the Neanderthals evolved into Homo sapiens or whether they became extinct remains a mystery. Apart from Africa and Europe, hominid remains have also been found in various parts of Asia. Remains of Homo erectus in Java have been dated between 1 to 2 Maya and were associated with animal bones of many species but no stone tools. Remains of Homo erectus discovered in the Zhukoutian caves 50 km southwest of Beijing are dated between 0.58 to 0.25 Maya. This site also yielded over 20,000 stone tools and bones of 96 mammalian species. What does it mean to be human? Homo sapiens are one of 180 species of primates, the highest order of mammals. They share some characteristics along with certain other mammals, but they also have their unique features. They are bipedal, that is, they walk upright on 2, not 4 legs. As an adaptation to bipedalism, their legs are longer than their arms, and their backbone has an S shape. Their hands are prehensile, i.e., are well suited to grasping. The fingers and large thumb, which can rotate through a 45-degree angle, can be used together to grip a stone tool or a pencil. Compared to other animals, their jaw is small and they do not have protruding canine teeth. Females of most animal species are sexually active only during limited periods known as estrus. Such a cycle is absent in human females. Human infants are born with undeveloped brains, only 25% of the full adult size, and remain helpless and dependent on maternal care for a very long time compared to other mammalian species. The story of hominid evolution is, among other things, a story of an increase in brain size. An increased brain size can be connected to greater memory storage, learning abilities, and more complex behavior. The average brain size of modern humans is large, 1,450 cubic centimeters, i.e. cubic centimeters, compared to that of chimpanzees, 393.8 cubic centimeters, Australopithecines, 507.9 cubic centimeters, and Homo erectus, 973.7 cubic centimeters. However, the issue is not just one of absolute brain size or weight, but brain size and weight in proportion to the total body size. The brain of an elephant is more than 3 times as heavy as that of a human. This doesn't make the elephant smarter than us. Similarly, the brain size of men tends on average to be larger than that of women. This does not mean that men are necessarily more intelligent than women. Humanness includes cultural as well as biological characteristics, and these have always been interdependent. Modern human behavior includes several traits, not all of which are easy to deduce from archaeological evidence. All animals adapt to and interact with their environment, but human communities have a greater ability to manipulate and transform their environment through the creation of specialized technology. It has been argued on the basis of experiments that chimpanzees and orangutans can make and use simple tools. But humans have a unique ability to make specialized tools, both varied as well as standardized, and travel considerable distances to obtain the desired raw materials. It is possible that orangutans can learn to use symbols for communication. But there is no doubt that the human thinking capacity is far superior to that of members of the ape family, and that human social behavior and cultural systems are far more diverse and complex than those of the apes. Other traits of human behavior include the organization and delimitation of living space, composers, structures, etc., symbolic thought and expression reacted in art, ceremonial or ritualistic activity, example burials, and ideas of individual and group identity. Some paleoanthropologists argue that while anatomically modern humans appeared on the Earth almost 200,000 years ago, fully modern humans, i.e., those whose behavior can be described as human in the senses mentioned above, appeared only about 50,000 years ago. Others argue that the earliest traces of some of these human traits can in fact be found in species other than Homo sapiens sapiens, for instance, among the Neanderthals as well as among some of the archaic hominids. Anatomically modern humans, known as Homo sapiens, seem to have appeared in Africa between 195,000 and 150,000 years ago, and eventually replaced all other Homo species. Important fossil remains have come from the site of Herto in Ethiopia, where hominid remains were found along with stone tools and animal bones in levels dated between 160,000 to 154,000 years ago. There are many questions to which there are yet no definite answers and which remain matters of debate. It is possible that Homo sapiens evolved in Africa and then migrated to various parts of Asia and Europe. Or, the migration out of Africa could have happened at an earlier stage, and modern Homo sapiens may have evolved from Homo erectus and archaic Homo sapiens more or less simultaneously on different continents. Evolution was not a neat unilinear process, one species making way for another. There is evidence from various parts of the world of the overlap and coexistence of species. For instance, the remains in Olduvai Gorge in East Africa show the coexistence of Homo habilis and Australopithecus, and there is similar evidence of the coexistence of the Neanderthals and anatomically modern humans in the eastern Mediterranean. Hominid remains in the Indian subcontinent. In sharp contrast to the widespread occurrence of animal fossils and stone tools all over the subcontinent, the evidence of hominid fossils is at present very meager. Kennedy, 2000, Chakrabarty, 2006, 10-16. This is no doubt due to inadequate investigations. From the 19th century onwards, several remains of fossil apes were discovered in the Siwalik Hills, the outermost range of the Himalayas. Given rather dramatic names such as Ramapithecus, Sivapithecus, and Brahmapithecus, they came to be collectively known as the god apes of the Siwaliks. Remains of Ramapithecus were subsequently found in other parts of Asia, Africa, and Europe as well, and were dated between 10 to 14 Maya. Ramapithecus, who lived in the Miocene-Pliocene transition, was once thought to represent the oldest direct ancestor of modern humans. However, this has been questioned on the basis of new dating methods and a reassessment of the fossil evidence. Authenticated early human remains in South Asia are relatively recent. In 1966, Louis Dupree discovered a fragment of a right temporal bone at the cave site of Dara-i-Khur in northeastern Afghanistan. The deposit in which it was found gave a radiocarbon date of 30,000 plus or minus 1900 to 1200 BPIE, 28,950 plus or minus 1960 to 1235 BCE. The fragment was considered consistent with Neanderthals as well as anatomically modern humans. The associated stone tools seem to belong to a Middle Paleolithic context. Several cave sites in Sri Lanka, Fahinlinut, Badadambalinut, Belilinut, and Alulina also yielded remains of anatomically modern humans in contexts ranging between 37,000 to 10,500 BP. More recently, hominid fossils have been found in central India. In 1982, Arun Sonakia of the Geological Survey of India made an important discovery near Hathnora village on the northern bank of the Nirmada, about 40 kilometers northeast of Hoshangabad. Here, embedded in thick, closely packed sandy, pebbly gravel, he found a fossilized fragment of a cranium, skullcap, along with some fossils of vertebrates, proboscideans and bovids, and a few late Aschulian tools. The skull fragment seems to have belonged to a woman about 30 years old. Sonakia suggested that she represented an advanced variety of Homo erectus, advanced because of her larger cranial capacity range of 1,155 to 1,421 cc, and named her Homo erectus narmadensis. However, according to other scholars, the cranium belongs to an early, archaic, variety of Homo sapiens. Its date too is uncertain. One view is that it belongs to the early part of the Middle Pleistocene, beginning about 500,000 BP. Between 1983 and 1992, the Anthropological Survey of India launched an intensive search for human fossils and tools in the central Nirmada Valley. This led to the discovery of hundreds of Paleolithic tools and some animal fossils. In 1997, Ir Songkyan announced important discoveries in the same boulder conglomerate deposit at Hathnora where the cranial fragment had been found some years earlier. These included a hominid clavicle, collarbone, along with animal fossils and several late or middle Paleolithic tools. Estimated dates of these NDS range between 0.5 to 0.2 Maya. Songkyan suggested that the two sets of human fossils found at Hathnora may well belong to the same woman. In 2001, P. Rajendran, a teacher in the Department of History of Kerala University, found a complete fossilized human baby skull in Ode in the Viluppuram district of Tamil Nadu. Rajendran was excavating a trench which had microliths in the upper levels and upper Paleolithic tools at the lower ones. At a depth of 6 m, just under the upper Paleolithic deposit, there was a ferricrete deposit, a mineral conglomerate consisting of sand and gravel, cemented into a hard mass by iron oxide. The skull was found close to this trench, embedded in a similar ferricrete deposit which was later dated 166,000 BP, placing it in the Middle or Upper Pleistocene. The antiquity of certain other reported hominid NDS is uncertain. This is the case with the two human mandibles of an adult male and female Homo sapiens found by H. D. Sankalia and S. N. Rajaguru on the bank of the Mula Mother River in Pune district, Maharashtra. The age of the mandible of an adult male found by V. S. Wakankar in a cave at Bhimbatka in Madhya Pradesh is similarly uncertain. Only a very minuscule proportion of the hominid record of the Indian subcontinent has so far been discovered. More concerted efforts are likely to add to the data and may transform the larger story of human evolution, which has so far concentrated more on Africa and Europe than on South Asia. Paleo-environments. The environments in which prehistoric people lived were very different from ours. Some of the major changes that gave the subcontinent its present form took place millions of years ago, in some instances long before hominids appeared on the planet. Hundreds of millions of years ago, the peninsula was part of a huge landmass that geologists call Gondwana land, which included Australia, Africa, South America, and Antarctica. At some point of time, this landmass broke up and the Indian landmass started drifting northwards at the rate of 20 centimeters a year, eventually joining up with the Asian landmass, between 50 and 35 Maya. All this was the result of the movement of massive tectonic plates embedded within the Earth. The collision and intermittent pressure of the Indian and Asian plates led to uplifts that resulted in the creation of the Tibetan Plateau and the Himalayas. Rivers brought down immense volumes of eroded sediments from the mountains, and this resulted in the creation of the fertile northern alluvial plain. The process of plate tectonics, the word tectonic means movements in the Earth's crust, is not over. The Indian plate continues to press into Asia at the rate of 5 centimeters a year. The Himalayas and the Tibetan Plateau are still rising at an average of 5 to 10 millimeters per year. Occasional movements in the tectonic plates lead to intermittent earthquakes and changes in the course of rivers in the northern parts of the subcontinent. All over the world, the Pleistocene era, which began about 1.6 Maya, was marked by dramatic climatic changes. The earlier idea of a sequence of 4 ice ages and 4 interglacial periods for the higher latitudes has been questioned. There seem to have been more than 4 ice ages and interglacials, corresponding to alternating periods of cold and warmer climate. During the cold phases, when ice sheets covered 1/3 of the Earth's landmass, sea levels fell dramatically. When the climate became warmer, the ice melted and sea levels rose. It is believed that the tropical and semi-tropical regions went through alternating dry and wet phases, interpluvial and pluvial phases, but the rhythm of Pleistocene climatic changes in these parts of the world is not fully understood. The Pleistocene environments of the subcontinent were influenced by larger global patterns of climate, but sometimes also by distant seismic events. For instance, about 75,000 years ago, a gigantic volcanic super-eruption occurred in Sumatra at a place today represented by Lake Toba. This seems to have led to a complex series of paleo-environmental changes in late Pleistocene times, which had a significant impact on hominid populations in the region. Tephra ash deposits arising from this eruption have been found embedded in river valleys in peninsular India, and the impact of the Toba eruption on hominid populations in this area is being studied. About 10,000 years ago, the Pleistocene era made way for the Holocene era, which continues into our own time, and the basic climatic patterns that prevail in the world today were established. This does not mean that there have been no significant climatic changes in the last 10,000 years. It is just that these changes have not been as enormous as those that occurred within the Pleistocene. The beginning of the Holocene was marked by wetter climatic conditions than those of the late Pleistocene. The study of the specific features of paleo-environments is a very important part of prehistory. Detailed paleo-environmental studies are so far available for very few parts of the subcontinent. One of the earliest such studies was conducted in 1935 by H. de Terra and T. T. Patterson on the Sohun River in the Potwar Plateau, between the Purpanjal and Salt Ranges in Pakistan. Their team found a large number of tools, mostly of the Middle and Upper Paleolithic, some of the Lower Paleolithic as well. De Terra and Patterson identified VE tool-bearing terraces. A terrace is an old bed of a river, of the Sohun, and tried to correlate these terraces with the theory of a fourfold glacial cycle in Kashmir, and further, with a fourfold European glacial cycle. This framework was extended, through comparisons, to the Nirmada and the area around Chennai. Although most of the correlations, sequences, and conclusions of the de Terra, Patterson study are no longer accepted, it marked an important stage in the history of prehistoric research in India. In 1930, L. A. Kamiad and M. C. Burkett carried out a similar study, correlating the stratigraphy of prehistoric stone tools and their environment in the eastern Ghats of Andhra Pradesh. Studies of the Sun Valley, in northern MP, and Bellon Valley, in southern UP, have thrown light on the connections between the changes in river systems, climate, and Stone Age sites in the valleys of these southern tributaries of the Ganga. Clark and Williams, 1986. During the late Pleistocene, the climate in this area was much cooler and drier than it is today. At the same time, hippopotamus and crocodile bones show that some permanent water was available in rivers and streams. In the early Holocene, the climate seems to have become warmer and wetter, probably leading to an expansion of forests and shrinking of grasslands. The Thar Desert today has very little naturally occurring surface water, except for short periods in the rainy season, and people have to rely on rainwater stored in tanks, wells, tube wells, and canals. A study of the western Rajasthan section of the Thar Desert, Misra and Rajguru, 1985, especially around Didwana in Nagaur district, indicates that the present environment of the Thar is very different from what it was like in the Pleistocene era. Except for a phase in the Upper Pleistocene, 25,000 to 13,000 BP, during most of that era, surface water in some quantity was always available. The flora and fauna was as a result much more abundant than it is today. The sediments of the salt lakes indicate a significant increase in rainfall in the mid-Holocene, 6,000 to 4,000 BP. It is not a coincidence that the most widespread prehistoric occupation in this area belongs to that period. Classifying the Indian Stone Age. The three-age system, the idea that there was an age of stone tools, followed by one dominated by those of bronze and then of iron, was put forward in the late 18th and early 19th centuries by the Danish scholars P. F. Sum and Christian Thomsen. The accuracy of this theory was proved by excavations by another Danish scholar, Jacob Wersa. The next important step was to identify changes within the Stone Age. In 1863, John Lubbock divided the Stone Age into two parts, the Paleolithic and Neolithic. A few years later, Edouard Lartet suggested the division of the Paleolithic into the Lower, Middle, and Upper Paleolithic, largely on the basis of changes in fauna associated with the different tool types. Archaeologists gradually identified distinct tool-making traditions within the Paleolithic and also recognized the significance of changes in subsistence patterns within the Stone Age. The use of the term Mesolithic is relatively recent. The Indian Stone Age is divided into the Paleolithic, Mesolithic, and Neolithic on the basis of geological age, the type and technology of stone tools, and subsistence base. The Paleolithic is further divided into the Lower, Middle, and Upper Paleolithic. A general time range for the Lower Paleolithic is from about 2 Maya to 100,000 years ago, the Middle Paleolithic from about 100,000 to 40,000 years ago, and the Upper Paleolithic from about 40,000 to 10,000 years ago. However, there is a great deal of variation in the dates for different sites. The Paleolithic cultures belong to the Pleistocene geological era, while the Mesolithic and Neolithic cultures belong to the Holocene era. While Table 2.2 explains the basic features of the different phases of the Stone Age, it also tends to oversimplify matters. It must be remembered that this classification is an analytical tool used by scholars to identify patterns across a very long and complex span of the human past. Except for the dividing line of the Holocene, Stone Age cultures did not evolve uniformly in a neat unilinear fashion all over the subcontinent. There are regional variations in some of their features, and their dates also vary considerably. The typical Indian tool types column in the table indicates the tools that are considered characteristic of that particular phase. However, it does not mean that there is complete uniformity in tools found at different sites, or that tools typical of one phase were absent in another. For example, celts are associated with the Neolithic, but are known to occur as late as the historical period in certain parts of eastern India. Similarly, with regard to the subsys. Table 2.2 Important features of the Stone Age. In space, it should be noted that hunting and gathering did not come to an end with the beginnings of animal and plant domestication. Many agricultural communities continued to hunt and forage for food. In fact, these subsistence activities continue to be prevalent in certain niches of the subcontinent even today. It is easier to identify and describe stone tools than to know whether, or to what extent, a community was producing its food through plant or animal domestication. Sometimes, there is insufficient data to reach a conclusion. Finally, there is the issue of overlap. Although there are some pure Neolithic sites in India, early agricultural sites frequently show an intermixture of Neoliths with copper and copper-alloyed objects. The Paleolithic Age. Lower Paleolithic sites. Paleolithic tools have been found in almost all parts of the subcontinent. Chakrabarti, 1999, 54-75, Alchin and Alchin, 1997, 47-85. Although hardly any sites have so far been discovered in the alluvial stretches of the Indus or Ganga valleys, Kalpianup is an exception. They have been identified on rocky areas within or on the margins of these valleys, example in the Rari Hills in Sindh and the northern fringes of the Vindhyas. Sites are prolific in other parts of the subcontinent, especially in peninsular India, leaving aside the coastal plains. Comparatively few Paleolithic habitation sites have been identified, but it can be assumed that people lived close to sources of food, water, and stone in different kinds of habitats, for instance, along the banks of rivers or streams and in caves and rock shelters. Excavated sites are comparatively few, and most of the evidence comes from surface NDS of stone tools. Because of insufficient data from most sites, it is necessary to focus on the published results of stone tools found in clearly denuded stratigraphic contexts. Some sites were inhabited over many stages of the Stone Age. Even in the absence of detailed studies, some broad inferences about Pleistocene climate can be made on the basis of the deposits in which Paleolithic tools are found. For instance, tools often get embedded in river terraces. Although a number of other factors are also involved, the erosion and deposition activity of rivers can be related to rainfall. Cemented gravel, a deposit in which small pebbles are packed tightly together in soil, is generally taken to represent a wet climatic phase. A boulder conglomerate, a deposit where larger boulders are packed together, is interpreted as representing a drier phase, while clay or silt deposits represent still drier conditions. Early Paleolithic tools were fairly large core tools made of quartzite or other hard rocks. They include chopping tools, hand axes, and cleavers. Apart from directly breaking off pieces of stone from large boulders, which would have required considerable strength, it is possible that people lit residential against rocks and threw water over them so that large fragments broke off more easily. Within the Paleolithic, there is a gradual increase in the range and variety of stone tools and a shift in preference from coarse-grained to any-grained stone. In recent years, important evidence of dates for lower Paleolithic contexts has come from the Potwar Plateau and the Siwa Lakes. At Dina and Jalalpur in the Jhelum Basin, Members of a British archaeological team discovered 15 artifacts including 3 hand axes in a boulder conglomerate deposit dated c. 700,000 to 500,000 years ago by the paleomagnetic method. There are much earlier dates from Raiwat near Rawalpindi in Punjab province of Pakistan. Here, in 1983, members of the British Archaeological Mission to Pakistan's Potwar project, working with the Department of Archaeology and the Geological Survey of Pakistan, discovered stone artifacts embedded in a stone conglomerate deposit dated 2.01 Maya by the paleomagnetic method. At the sites of Gurhasahan and PS57, stone tools were found embedded in the Pinjore bed of the Siwaliks, dated between 2.4 and 2 Maya. Stone tools reported in the Jammu and Himachal sections of the Siwalik Hills seem to belong to about the same age. For instance, at Utarbani in the Jammu area, early Paleolithic tools were found in a deposit dated 2.8 plus or minus 0.5 Maya. Typical Lower Paleolithic tools. Stone tools are an important key to understanding the lives of prehistoric humans. It is therefore very important to understand the meaning of terms used by prehistorians for different stone tool types, especially since some of them can be rather misleading. If you take a piece of stone and break it into 2 or more pieces, the largest piece is called a core and the smaller piece, or pieces, are called aches. A stone tool made out of the largest piece, core, is called a core tool, while tools made out of the smaller pieces, aches, are called ache tools. Removing slivers or pieces from a rock is called acheing. The depressions or marks formed on the surface of a stone when aches are removed are known as ache scars. A hand axe is generally a core tool. It is also known as a biface, because it is usually worked on both sides. Generally made on a core, it is roughly triangular in shape, broad at one end and pointed at the other. Not all hand axes were handheld tools, some of them could have been hafted onto handles. Pebble tools are tools of different types made on pebbles, in which only the working edge is ached, the rest of the tool remaining untouched. A chopping tool is a tool made on a core or a pebble and is ached alternately on both sides to produce a wavy cutting edge. A chopper is a large, unifacial tool, i.e. worked on one side only. A cleaver is a addish tool made on a broad rectangular or triangular ache, on one end of which is a broad and straight cutting edge. The term Aschulian is often used to refer to an assemblage of stone tools marked by advanced and increasingly symmetrical hand axes and cleavers. These are associated with the Lower Paleolithic, but continue well afterwards as well. Sars Sankalia 1964, 1982, 45-58. Some absolute dates are now available for Lower Paleolithic contexts in other areas as well. Didvana in Rajasthan has been dated 390,000 BP, by the uranium/thorium series dating method. In the Hiran Valley in Gujarat, the Lower Paleolithic context is dated 190,000 to 69,000 BP, via the uranium/thorium series dating method. For the Sun Valley, MP, there is a thermoluminescence date of 103,800 plus or minus 19,800 BP. Nevasa, in Maharashtra, has given a date of 350,000 BP, via uranium/thorium series dating. In Karnataka, the site of Yejarwadi has been dated 350,000 BP. Factory sites are generally located close to the sources of raw materials and are marked by a profusion of stone tools in various stages of preparation. In many instances, they were visited and used during several phases of the Stone Age, sometimes even later. In Sindh, there are a number of such sites in the limestone hills capped by nodules. In Lower Sindh, stone tools belonging to the Lower, Middle, and Upper Paleolithic were found at sites such as Jaruk and Milestone 101. In Upper Sindh, there are factory sites in the Sukar and Rari Hills. Many people tend to think of Stone Age sites as distant, isolated places. As a matter of fact, Stone Age tools are often found in places that are today bustling with activity. A good example are the many sites found in and around the modern city of Delhi. 4 Lower Paleolithic stone tools were found in 1956 on the Delhi Ridge, near the main gate of the University of Delhi, and more were subsequently discovered on the northern ridge. In 1983, a late Aschulian hand axe was found on the campus of Jawaharlal Nehru University. A systematic study of Stone Age sites in South Delhi and adjoining areas, Chakrabarti and Lahori, 1986, identified 43 sites ranging from the Lower Paleolithic to the Microlithic. Excavations at Anangpur in the Budrupur hills to the south of the city revealed thousands of early and late Aschulian tools along with traces of several paleo channels of the Yamuna River. The evidence indicates that this was a large Lower Paleolithic habitation and factory site. In Rajasthan, Lower, Middle, and Upper Paleolithic tools have been found around Ajmer, and stray NDS of Lower Paleolithic tools occur in the Luni Valley. There is a detailed Pro-Eli of the Didwana area of the Nagaur district in western Rajasthan, with a sequence extending from the early to the Middle Paleolithic. The Magara Hill near Jodhpur seems to have been a factory site where Lower, Middle, and Upper Paleolithic as well as Mesolithic tools were made. In Gujarat, Lower Paleolithic tools have been found in the valleys of the Sabarmati, its Orsang and Karjun tributaries, and in the Badar Valley in Saurashtra. Lower Paleolithic and later artifacts have been found all along the Konkan coast up to Goa. In Maharashtra, Paleolithic tools have been found in many places along the coast and in the Vardha, Wainganga valleys. Stratigraphic prolay of sections of the Mula-Mudha, Godavari, Pravara, and Tapi rivers are available. Lower and Middle Paleolithic tools have been found in stratigraphic contexts in the Duttawadi area of the Mother River in Pune. Lower Paleolithic tools have been found in a stratigraphic context in the Gangawadi area on the Godavari at Nasik. Prehistoric remains occur in various parts of central India and Dhamma, Raisin, and the Nirmada, Upper Sun, and Mahanadi valleys. The Nirmada Valley is an especially rich and well-researched area. Excavations at Adamgarh Hill, not far from Hoshangabad, revealed a sequence of Lower and Middle Paleolithic tools. However, the most spectacular NDS come from hundreds of rock shelters at Bhimbatka, in Raisin district, MP, 30 kilometers north of Hoshangabad, which have given evidence of an enormously long sequence of occupation stretching from the Lower Paleolithic to the historic period. The Bhimbatka hillside is composed of sandstone and quartzite. There are 3 perennial freshwater springs in the area, and several creeks LLED with water. A study of the present-day aura and fauna indicates the presence of at least 30 plant types which yield edible fruits, tubers, and roots. There are sh in the streams, and the hillside is home to many animals such as the deer, boar, nilgai, leopard, wolf, hare, and fox. Of course, in prehistoric times, conditions wouldn't have been exactly like this. Nevertheless, it is clear that this site must have been attractive for Stone Age people from the points of view of shelter, food, and raw material for tools. Most of the stone tools at Bhimbatka were made of a yellowish quartzite available in plenty in the area, but a grey quartzite was also obtained from further away. Fivers paved with it stone slabs belonging to the Lower Paleolithic were identified. No bones have been found so far, perhaps because of the acidic soil. In the Bellon Valley in Uttar Pradesh, detailed studies have revealed a sequence of Stone Age industries from the Lower Paleolithic to Neolithic to Proto-Historic. In Bihar in eastern India, a Lower Paleolithic living and working ore was excavated at Paisra in the Kudgapur forests near Munger, Pant and Jaiswal, 1991. The whole area was rich in niched and unniched artifacts, broken pieces of stone, and anvils. 8 post holes were found, marking places where wooden posts had been dug into the ground to support thatched huts. The river valleys and foothills of the Khotanagpur Plateau in Jharkhand and the adjoining areas of West Bengal have yielded Lower Paleolithic tools. In Orissa, tools of all 3 phases of the Paleolithic have been found in many places. A large number of Lower and Middle Paleolithic tools were found in explorations at Dari Dungri in Sambalpur district, and Lower Paleolithic tools have also been found along the valleys of the Budhabalan and Brahmani rivers. At one time, it was believed that the Lower Paleolithic industry of the south, which was given the name Madrishyan, was different from that of other parts of the country because of a supposed absence of pebble tools. The research of the past few decades has proved that this is incorrect, and that pebble tools such as choppers and chopping tools are found along with hand axes at several sites. A stratigraphic sequence of Lower and Upper Paleolithic tools was identified in the Malaprabha, Ghataprabha valleys in Karnataka. Lower Paleolithic tools have also been found in the Hunsgi, Bayakbal and Krishna valleys. Lower Paleolithic tools occur at many places at Hunsgi, in the Gulbarga district of Karnataka, on the banks of the Hun Sgi, a tributary of the Krishna River, Padaya, 1982. Here, sites with very few types of artifacts may represent places where certain specific activities such as making tools or killing game were carried out. Sites where tools occur in larger number and variety, may have been temporary campsites. Still larger sites, where stone tools have been found in great profusion and variety, may have been places where groups of people lived for long periods of time. The Hunsky tools were mostly made of various kinds of stone including limestone, sandstone, quartzite, dolerite, and chert, some of which were not locally available. In one of the excavated areas, huge granite blocks were arranged around a 63 sqm area, perhaps used as a support for temporary shelters made of branches, grass, and leaves. Today, the area around Hunsky supports about 40 types of wild edible plants as well as plenty of small game. In Andhra Pradesh, lower Paleolithic tools have been found in inland areas as well as the coastal Visakhapatnam area, where they have been connected to a sea level over 7 m above the present one. Nagarjunakonda, one of the sites that have been studied extensively, has given paleoclimatic evidence of 3 alternating wet and dry cycles. Chop purse and scrapers made of quartz have been found in the Palghat district of Kerala. In Tamil Nadu, there is a stratigraphic sequence from the early Paleolithic to the Mesolithic from near Chennai. Goody Yam Cave, not far from Chennai, has yielded a sequence of lower, middle, and upper Paleolithic tools. The fewness of the tools and the absence of other remains suggest that the site was occupied for short periods of time. Atayirampaksam, in the Cordillera River Basin, is one of the richest Paleolithic sites in Tamil Nadu, Puppu et al., 2003. The site was discovered in 1863, and has been excavated, off and on, since then. The most recent excavations revealed a sequence of lower, middle, and upper Paleolithic cultures, with a break in occupation after the Middle Paleolithic. Aschulian tools were found in a 4 m thick deposit of clay. The artifacts, mostly hand axes, were made of quartzite stones that were not available locally. Very little debitage was discovered at the site, suggesting that the tools were made somewhere else and then brought here. One of the most interesting discoveries was a set of animal footprints found along with Aschulian tools. The 17 round impressions, 15 to 20 centimeters, of animal feet in a set of hoof prints are still being studied by experts. This is the RST discovery of its kind in South Asia. Another interesting discovery was of 3 animal fossil teeth, possibly those of some kind of horse, water buffalo, and nilgai, suggesting an open and wet landscape in early Paleolithic times. Izampur, a center of stone tool manufacture. Izampur, Gulbarga district, Karnataka, is a village located in the northwestern part of the Hunsky Valley, drained by a small seasonal stream known as the Kamtahala. The Paleolithic site lies about 2 kilometers northwest of the village, close to the bank of the stream, covering an area of about 7,200 sqm. It was discovered in 1983, when the silt deposits overlying the limestone ore of the valley were exposed due to quarrying activity carried out as part of a major irrigation project. This site offered some obvious advantages to prehistoric humans. Water and a variety of wild animal and plant food were available. Another advantage was that siliceous limestone blocks and slabs occur plentifully in the area at the intersection of it and steep surfaces. There is evidence of Aschulian as well as Middle Paleolithic occupation at the site. The Aschulian material mostly consisted of cores in different shapes, large axe, and debitage, waste material. The main tool types were chopping tools, knives, hand axes, cleavers, and scrapers. While unniched tools occurred in large numbers, there were relatively few niched ones. Hammer stones of different sizes, made of hard rocks such as quartzite, basalt, and chert were found in very large numbers on the surface and in the excavated levels. There is evidence of quarrying and of different stages in tool manufacture. The Middle Paleolithic assemblage consisted of 8 tools, mostly made out of locally available chert nodules. These included niched tools, cores, hammer stones, axe, and debitage. There were also tools made of quartzite and limestone. Scrapers of various types were the most numerous. Tools were made both by simple aching and through the use of a prepared core technique. The site consisted of 4 sub-localities, each measuring 300 to 400 sqm, within which there were many limestone slabs and blocks suitable for making tools. These rocky patches must have been centers of tool-making activity. Given the large extent of the site and the huge number of tools found here, it seems that Izampur was one of several hubs of stone tool manufacture in the Hunsky, Bhimbatka valleys, from where hominids must have ranged out to the valley or in the uplands for foraging. Some of the tools found here are weathered and have use marks, showing that the site was also a habitation site where people lived and carried out subsistence activities such as food processing. The prehistoric occupation at Izampur seems to go back to between 500,000 and 600,000 years ago. The continuing investigations at this site are likely to provide further valuable data about the Lower Paleolithic. Sarspadde Ya etal, 1999–2000. Middle Paleolithic sites. Within the Paleolithic, there were gradual changes in stone tools. Hand axes, chopping tools, and cleavers did not altogether disappear, but the balance shifted towards smaller, lighter ache tools, some of them made by prepared core techniques, including the Laval-Loess technique. Middle Paleolithic tools have been found in many parts of the subcontinent, of in river gravels and deposits, which give clues about prevailing climatic conditions. There are some dates for Middle Paleolithic contexts. Didvana, Rajasthan, has given two thermoluminescence dates of 150,000 BP and 144,000 BP. The Hiran Valley, Gujarat, has yielded a uranium, thorium series date of 56,800 BP. In the northwest, lots of stone tools, mostly of the Middle Paleolithic, have been found in the Potwar Plateau between the Indus and Jhelum rivers. The over 3 m thick deposit in the Sanghau Cave in the northwest frontier province of Pakistan revealed a sequence of Middle and Paleolithic occupation. Thousands of stone tools were found, along with bones, of animals, some perhaps of humans, and hearths. All the tools are made of quartz, which is easily available around the site. Many of the tools of period I were made from aches stuck from prepared cores, and there were lots of burins. In the Thar region, Middle Paleolithic artifacts occur in reddish-brown soil, which indicates more abundant vegetation, more surface water, and a cooler, wetter, and more humid climate compared to Lower Paleolithic contexts. Small factory sites and campsites have been found in various parts of the Thar, especially near rivers and lakes. A large number of Stone Age sites belonging to the Middle Paleolithic phase onwards are located around Buddha Pushkar Lake, an area which offers advantages of the easy availability of water and stone. Middle and Upper Paleolithic tools are also found around Ujmer. There is evidence of Middle Paleolithic working ores at Hakra and Baradhani. The Laval-Loess technique. The Laval-Loess technique is an advanced way of making ache tools. It is named after a place called Laval-Loess Paray near Paris, where this technique was noticed on prehistoric stone tools. Instead of breaking off a ache and working on it to produce the desired shape, the core was carefully prepared. Its sides were trimmed, and aches were then systematically removed from its surface, from the center outwards in all directions. Then, a striking platform was created by attening the top of the prepared core, and perpendicular blows were struck at that point, either directly or through an intermediary tool. The ache detached in this way was thin, roughly triangular, or oval in shape, with a clean undersurface, and shallow, centrally directed ache scars on the upper side. It would need very little further working, because its edges were already sharp. Because the core of a Laval-Loess ache looks like the shell of a tortoise, it is sometimes referred to as a tortoise core. There are other prepared core techniques as well. For instance, in the discoid core technique, aches are scalloped from the circumference of a large core or ache with at least one at side. The remaining core has a beveled rim and is in the center. The Laval-Loess technique can be used to produce only one ache at a time, while the discoid core technique can produce several aches. Flakes produced by the latter method tend to be small. Sars Sankalia 1964, 1982, 29–30. Close to the now dried up lakes. In the Jaslumar area, Upper Paleolithic material is not as abundant as are artifacts of the Middle Paleolithic. Middle Paleolithic sites have also been located along the now virtually extinct Luni River system. The term Luni industry is used for Middle Paleolithic assemblages west of the Aravalis, and can be contrasted with the industry of the regions lying east of the Aravalis. Although certain forms are common to both areas, sites to the west of the Aravalis display more variety in stone tool types and larger numbers of reworked aches. Middle and Upper Paleolithic tools have also been found along the eastern margin of the Gujarat plain. The Middle Paleolithic industry of central and peninsular India is sometimes referred to as the Nevasan industry after the site of Nevasa, where the pioneering archaeologist H.D. Sankalia RST discovered Middle Paleolithic artifacts in a stratigraphic context. The tools, which include a wide variety of scrapers, are made of smooth, any-grained stone such as agate, jasper, and chalcedony. Patently in the Tapi Valley revealed a stratigraphic sequence of Middle and Upper Paleolithic and Mesolithic tools. There is evidence of a Middle Paleolithic living and factory site at Cherki near Nevasa. The earliest trace of human occupation in the Gunga Plain is found embedded in a 20 m thick cliff section at Kalpi, in Jalan district, up, on the southern bank of the Yamuna. A number of vertebrate fossils, elephant tusk, shoulder blade of elephant, molars of equus and bovids were found here. Middle Paleolithic stone tools, including pebble tools, points, and side scrapers, and bone tools, such as end scrapers, points, and burins, were found along with them. The tool-bearing level at Kalpi has been dated about 45,000 years ago. There are several Middle and Upper Paleolithic sites further east, especially in the western part of West Bengal. In South India, the Middle Paleolithic culture is marked by a tool industry. On the Visakhapatnam coast, quartzite, chert, and quartz were frequently used to make stone tools. There is evidence of tools made by the Lavalois technique at many places. In addition to smaller hand axes, cleavers, and choppers, the Middle Paleolithic toolkit included new tool types such as scrapers of different shapes. A C14 date for the Middle Paleolithic context at the coastal site of Nandapalli in Kadapa district indicates that it is older than 23,000 years ago. Upper Paleolithic sites. The important technical advance of the Upper Paleolithic was the making of parallel-sided blades. There was also an increase in the number of burins. The trend was towards smaller tools, and this must have been due to adaptations to environmental changes. It is known, for instance, that the climate of northern and western India seems to have become increasingly arid during the Upper Paleolithic. Older tool types continued to be made for activities that required heavier tools. There are some dates for Upper Paleolithic contexts. Site 55 at Raiwat gives the earliest date for the Upper Paleolithic c. 45,000 years ago. C14 dates from the Sanghao cave range from 41,825 plus or minus 4,120 BCE to 20,660 plus or minus 360 BCE. In central India, the Sun Valley has given radiocarbon dates within the range of 12,000 to 10,000 BP, and a piece of ostrich eggshell at Mehtakari has been dated to over 41,900 BP. Two dates from the Kurnool caves, in Andhra Pradesh, are 19,224 BP and 16,686 BP, based on the electron spin resonance method. In the northwest, the Sanghao cave has given evidence of Middle and Upper Paleolithic tools, hearths, animal bones, and what appear to be burials. Upper Paleolithic tools have also been found in the Rari Hills in Upper Sindh and Milestone 101 in Lower Sindh. In North India, the Kashmir Upper Paleolithic has been dated to about 18,000 BP and coincides with the onset of a milder climate. In the Dhar, the number of Upper Paleolithic sites is fewer than those of the Prekding phase, due to increasing aridity. However, there was continuing human occupation around the Buddha Pushkar Lake. In central India, Upper Paleolithic habitation sites have been found in caves and rock shelters of the Vindhyas. The Upper Paleolithic context in the Bellon Valley has been dated between 25,000 and 19,000 years ago, and that of the Sun Valley about 10,000 years ago. Chopini Mondo in the Bellon Valley seems to be a habitation site with a cultural sequence from the Upper Paleolithic to Neolithic. The Upper Paleolithic assemblage consisted of tools made from chert, a stone available in the nearby Vindhyas. The animal bones discovered in the Bellon Valley included those of wild cattle, sheep, and goats. Since sheep and goats do not seem to be indigenous to this area, they may have been brought here from the northwest. If this was indeed the case, it could represent an early stage of animal domestication. In the district of Madhya Pradesh, in the valley of the Sun River, an archaeological team led by G.R. Sharma and J.D. Clark excavated the Upper Paleolithic site of Bugurai. A subsequent microware study of the site Bugur 3, not far from Bugurai, Sinha, 1989, has thrown light on the subsistence activities of this phase. The study identified the different kinds of activities that the stone tools found at the site were used for. Some of these activities, such as boring, scraping, and whittling, were probably related to craft work. Others, such as cutting, slicing, piercing, and chopping, could have been associated with food processing, hunting, or craft work. Microware analysis identified the proportion of tools used on vegetal materials, those used for processing non-vegetal material, and those used to work on wood or bamboo to make hunting and gathering gear. Some tools showed a kind of wear and polish that indicated they had been hafted onto handles. There are many Upper Paleolithic sites in the Khotanagpur region and the Daman area of the Rajmahal Hills. These include Paisra and Munger district. Upper Paleolithic tools have been found in the various districts of West Bengal. There is not enough evidence of the Paleolithic phase in Assam and other parts of the northeast. But in the Lalma Hills of Bangladesh and in the Haira and Kovayi River valleys in western Tripura, a number of tools, including typical Upper Paleolithic types such as blades, burins, points, etc. made out of fossil wood have been found. Similar tools have been found in the Upper Irrawaddy Valley in Myanmar. The Upper Paleolithic cave sites of Kurnool and Muchchatla Chintamanu Gavi in Andhra Pradesh are the only places in the subcontinent where tools made of animal bones have been found in an Upper Paleolithic context. In one of the caves, as many as 90% of the excavated tools were made of this material. The funnel remains at the site included those of the bat, nilgai, four-horned antelope, gazelle, cheetal, somber deer, barking deer, mouse deer, wild boar, tiger, leopard, jungle cat, rusty spotted cat, spotted hyena, civet, freshwater sh, mongoose, sloth bear, porcupine, bandicoot rat, gerbil, a rodent, mouse, bush rat, black-naped hare, grey langur, baboon, horse, ass, rhinoceros, shrew, and giant pangolin. Apart from giving valuable information about the animals that Upper Paleolithic people shared their landscape with, this list also suggests that thick forests and more humid conditions prevailed in this area. Upper Paleolithic artifacts were also found in a cave at Renegunta in Chittor district of southern Andhra Pradesh. Stone tools of this phase occur at many places along the east coast of peninsular India, and their antiquity ranges between 25,000 and 10,000 years ago. Paleolithic art in cults. Prehistoric art marks the beginning of the history of art. It is also an important window into the world of prehistoric people. Apart from paintings on rocks, rock art includes petroglyphs, a word used when some substance of a rock surface is removed through engraving, bruising, hammering, chiseling, or scooping. Prehistoric art can occur in permanent places, example cave paintings, or can be portable, example figurines. Such remains were clearly an integral and important part of community life, and some of them seem to have had some sort of cultic or religious significance. In Europe, Australia, and southern Africa, there is clear and considerable evidence of Upper Paleolithic rock paintings and engravings. Animals are the predominant motif, and some of the representations may have been part of hunting rituals. Female figurines known as Venus figurines may represent fertility beliefs and rituals. In India, however, there is very little evidence of Paleolithic art. This is partly because most of the evidence must have perished over time. However, much still remains to be discovered. We may in fact have to read any what we consider as art in order to recognize the remains of artistic activity of prehistoric people. It has been suggested that some of the paintings at sites such as Bhimbatka go back to the Upper Paleolithic period, but this is far from certain. There are problems in dating and interpreting prehistoric art, and of ascertaining if an object was simply utilitarian or whether it had some other sort of function and significance. For instance, a very damaged Upper Paleolithic carved bone object found at Lohandinala in the Bellon Valley, has been identified as a mother goddess figurine by some and as a harpoon by others. Animal teeth found in a cave at Kurnool have grooves which suggest that they may have been attached to a string and worn as ornaments. A circular disc made of chalcedony at Bhimbatka and a soft sandstone disc at Mahar, southwest of Allahabad, were found in Aschulian contexts. Neither seem to be tools. A piece of ostrich eggshell engraved with two panels of criss-cross designs was discovered at Patni. 4 perforated beads and 1 incomplete bead made of ostrich eggshell came from Patni and 1 from the Bhimbatka rock shelters, all from Upper Paleolithic contexts. Dramatic evidence of artistic cultic activity comes from Cave 3F24 at Bhimbatka, known as the Auditorium Cave. This seems to belong to the borderline between the Lower and Middle Paleolithic. A roomy tunnel, about 25 m long, leads into a hall which has 3 other entrances. In the middle of the cave is a large rock. The part of the rock facing the tunnel is at end vertical. On it are 7 cupules, cup-like depressions, up to 16.8 mm deep. A few meters away from this rock, at the bottom of a pit, is another huge rock. This has one single large cup mark, along with a meandering line carved on its surface. One interpretation is that the rock with multiple cupules was used as a rock gong and that the marks were made when it was hit repeatedly. It is more likely that they were deliberately made as part of some important prehistoric community ritual. The site of Bagurai in Madhya Pradesh has given fascinating evidence of an Upper Paleolithic shrine dated c. 9000 to 8000 BCE. Here, there was a roughly circular platform made of sandstone rubble, about 85 centimeters in diameter. In the center was a piece of natural. Further discussion. Ostrich eggshell beads. The ostrich, Struthiocamelus sp., the largest living bird in the world, is today found in its natural habitat only in Africa, where it teeters on the verge of extinction. However, there is clear evidence that ostriches roamed over many parts of Asia, including India, till the end of the Pleistocene or early Holocene. Ostriches may have been hunted for food, and their eggs must also have been eaten. The eggs are big. Their size ranges from about 127 × 103 mm to 160 × 129 mm, with an average thickness of 1.97 mm. They weigh between 775 g to 1618 g. The shell is smooth, yellowish-white, speckled with black. It is so hard that you have to use a hammer and saw to break it. The shells could have been used as bowls or containers. Fragments of ostrich eggshell have been found in Upper Paleolithic contexts in India. The RST discovery was made in the 1860s in the Ken River in Bunda district of Uttar Pradesh. Since then, pieces of ostrich eggshell have been found at Patni in Maharashtra, and about 50 discoveries have been made in various parts of Rajasthan, Madhya Pradesh, and Maharashtra. A few of the eggshell pieces have been dated. Patni gives a date of 25,000 years BP, Chandresal, in Rajasthan, gives 2 dates 38,900 plus or minus 750 BP and 36,500 plus or minus 600 BP. Ramnagar, in Madhya Pradesh, gives a date of over 31,000 years BP. Some eggshell pieces have patterns on them. When examined carefully under the microscope, most of these seem to be the result of natural weathering. However, the fragment found at Patni is clearly engraved with criss-cross patterns made long ago by human hands. Beads and discs for ornaments were also made out of ostrich eggshell. Some of them had a hole through which they could be strung. About 41 Indian sites have given evidence of such beads in Pleistocene contexts ranging from 39,000 to 25,000 BP. For instance, ostrich eggshell beads occur in Upper Paleolithic contexts at Patni and Bhimbatka. The Patni beads have a diameter of about 10 mm and the Bhimbatka ones of 6 mm. The Bhimbatka beads were discovered in an Upper Paleolithic burial in a rock shelter, on the neck of the skull of a buried man. He must have been wearing a necklace with different kinds of beads. The others had decayed, but the 2 ostrich eggshell beads survived. Making such beads must have required considerable skill and care, and some scholars have tried to replicate them experimentally. G. Kumar worked with heavily weathered ostrich eggshell and used Mesolithic tools, drilling through both sides, to produce 2 perforated beads. It took him 10 to 12 minutes. R. G. Bednarik used fresh ostrich eggshell. He found that it was best to work with tools made of coarse-grained quartzits and quartz, and managed to drill through the shell of a complete egg in 70 to 90 seconds. Through experimentation, he also reconstructed the process whereby beads of this material must have been made. Figure 2.8 Decorated ostrich eggshell objects. Although the number of surviving beads is small, these must represent a very small proportion of those made and used by prehistoric people. Small beads could not have achieved a decorative result singly or in small numbers. The role and function of such beads must have been non-utilitarian, symbolic, or ideological. They must have been produced with such care and perfection because they were imbued with important cultural meaning. The beads also display an appreciation of an essentially abstract form. Beads made of ostrich eggshell have also been found in Upper Paleolithic contexts in Siberia, Inner Mongolia, China, and Africa. Clearly, Ornaments made out of this material were the fashion in many parts of the prehistoric world. Bushmen of southern Africa are known to have used ostrich eggshell for making beads and as water vessels till recently. Sars Bednarik, 1997. Stone with a striking pattern of concentric triangular laminations in colors ranging from a light yellowish red to a dark reddish brown. Archaeologists found 9 other fragments of this stone, mostly on or near the platform. When the 10 pieces were joined together, they formed a triangle about 15 centimeters high, 6.5 centimeters wide, and 6.5 centimeters thick. This triangular stone was evidently originally placed on the platform. It is interesting to note that the Kol and Biga tribal people who live in this part of the Khmer Hills today make circular rubble platforms and worship similar triangular stones as a symbol of the female principle or as an icon of a goddess. The lifeways of Paleolithic hunter-gatherers. The lifeways of Paleolithic people living in different parts of the subcontinent were based on their adaptations to their specific environments. However, there were some basic similarities in the lives of these hunting-gathering communities. Ethnographic studies of modern hunter-gatherers can supplement the information from archaeology, although caution has to be exercised while drawing parallels and conclusions. Paleolithic people lived in shelters made of rock, branches, grass, leaves, or reeds. More and less permanent settlements can be identified and some sites represent specific kinds of activities. Habitation sites such as Bhimbatka and Hunsgi give evidence of continuous occupation over centuries. Other sites indicate temporary campsites, where people came, lived for some part of the year, and then moved on. Still others were connected with specific activities, e.g., kill or butchery sites and factory sites. As mentioned earlier, some factory sites seem to have attracted many different communities over thousands of years. Food resources now and then. Due to the lack of organic plant and animal remains, archaeologists often draw on ethnographic evidence of present communities living in areas that once supported prehistoric populations. Some important case studies have tried to understand Paleolithic sites within their broader environmental and settlement contexts. K. Padaya's study of the settlement and subsistence patterns of the lower Paleolithic culture of the Hunsgi Valley identified about 40 species of wild edible plants growing in the valley today, including fruits, berries, pods, leafy vegetables, mushrooms, and seeds. The valley does not support any large wildlife today, except perhaps the gazelle and black buck. But fossilized bones of wild cattle, Bos sp, and a horn fragment of a deer were found at the middle Paleolithic site of Hagargandiji on the Bhima River, about 80 kilometers to the northeast. Kudikal, a Neolithic site situated 8 kilometers from the Hunsgi Valley, yielded remains of 3 species of deer, the Barasinga, gazelle, and spotted deer. It is reasonable to assume that thousands of years ago, such animals were present in the Hunsgi Valley as well. The valley still supports a variety of small mammals, birds, reptiles, and aquatic animals. These include the hare, porcupine, birds such as the sand grouse, partridge, and quail, reptiles such as the monitor lizard, many varieties of sh, and several types of insects. Some of these resources are routinely exploited for food by local communities living in the area today. The present flora and fauna of the Hunsgi Valley gives us an idea of the range of wild plant and animal food available to prehistoric people who lived in this area thousands of years ago. Of course, in those times the area must have had a much thicker vegetation of savanna woodland and must have supported a much richer range of flora and fauna. Padaya suggests that in view of the fact that the plant resources of the area shrink in the dry summer months, prehistoric people must have had to rely more on hunting animals for food during that period. MLK Murty's study focused on present-day hunting-gathering tribes of Andhra such as the Urakulas, Yana Ndis, Chenchus, and Boyas, as well as incipient agricultural groups such as the Gonds and Kondar Redis. These communities still depend on wild forest food, small game, reptiles, riverine, and sea fauna, insects, and honey. Murty listed about 80 edible wild plants used by these people, including fruits, berries, seeds, tubers, pods, pulps, and vegetables. He pointed to a broad congruence of the location of prehistoric hunter-gatherer sites and those inhabited by present-day tribal communities relying significantly on hunting and gathering. This indicates that the ecological niches that were exploited by prehistoric communities who lived by foraging and hunting still manage to support communities who rely on similar subsistence strategies. Sarspadaya, 1985, Murty, 1985. The basic social structure of Paleolithic hunter-gatherers may have corresponded in some ways to what anthropologists call a band society, although caution always has to be exercised while invoking ethnographic parallels. Bands are small communities, usually consisting of less than 100 people. They tend to be mobile or nomadic to some extent, moving from one place to another, depending on the seasonal availability of the animals they hunt and the plant food they gather. Members of a band are usually related to each other through kinship, and their division of labor is based on age and sex. The exchange of goods is based on rules of reciprocity, not on commercial exchange. Within the band, no single person or persons owns the natural resources they all depend on. There are no institutions of formal government, no formal or permanent leaders, not even the powerful chiefs seen in more complex tribal societies. The behavior of members of the group is not regulated by force but through customs, norms, and social etiquette. One of the stereotypes about the life of hunter-gatherers is that theirs was a constant, relentless struggle for survival with little or no leisure time. The material desires and wants of Paleolithic humans must have been relatively limited, and their technology did not permit them to hoard food beyond a point. These two factors meant that their subsistence-related activities ceased when they had obtained enough food. This must have given them some time for other kinds of activities. Ethnographic evidence in fact shows that not all modern hunter-gatherers live a hand-to-mouth existence, and many of them have plenty of leisure time to sleep, chat, play games, and relax. Another commonly held view is that hunting-gathering is an inefficient mode of subsistence. This can be questioned on the basis of the long history of this mode of subsistence and its continuation, of course on a much reduced scale, even into our own time. Further, ethnographic studies have shown that many hunting-gathering groups do not fully exploit the natural resource potential of their area, and that they consciously practice sensible restraint in their exploitation of the environment in order to conserve its resources. Modern hunter-gatherers tend to obtain a significant amount of their food through gathering rather than hunting. This suggests that the hunting part of the term hunter-gatherer has perhaps been overemphasized by scholars and the gatherer part neglected. This conclusion has important implications for understanding subsistence patterns as well as gender roles and relations in Paleolithic societies. In most modern hunting-gathering communities, men hunt and women gather food, and a similar division of labor probably existed in Paleolithic times. But if plant food had a greater dietary importance, it can be inferred that women must have contributed in a major way to the subsistence base of Paleolithic communities. The artistic, social, and cultic implications of some of the specimens of Paleolithic art have already been mentioned. Modern hunter-gatherers regard themselves as part of a larger world of nature because of their daily and direct encounter with it. Animals, plants, and aspects of the landscape may be treated as kin or foe, they may be worshipped or may form the focus of rituals. Since modern hunter-gatherers maintain some degree of contact with more complex societies, it would be a mistake to assume that prehistoric people had identical beliefs. However, it is possible that there were some very broad similarities arising out of a similar type of subsistence base. The Mesolithic Age. Mesolithic sites. The Pleistocene geological era made way for the Holocene about 10,000 years ago. Many environmental changes took place during this transition, and there are detailed prolae of climatic patterns for some parts of the subcontinent. For instance, an analysis of soil samples from the site of Bhimbatka in West Bengal shows a trend of increasing aridity. On the other hand, the study of the salt lake sediments and pollen grains at Didwana in western Rajasthan suggests higher rainfall at this point of time. In eastern Madhya Pradesh, the climate of the early and middle Holocene seems to have been wet and warm, with heavy rainfall in the summer monsoon months and moderate levels of rainfall in winter. A drier spell seems to have set in about 4,000 to 3,000 years ago. Towards the end of the Pleistocene or beginning of the Holocene, there were certain changes in the stone toolkits of prehistoric people. People started making and using very small tools referred to by prehistorians as microliths. At sites such as Patni, where there is a long and continuous stratigraphic sequence of prehistoric occupation, the gradual decrease in the size of stone tools can be seen very clearly. The term AP Paleolithic is sometimes used for the transitional stage of tools that are smaller than those typical of the Upper Paleolithic, but smaller than microliths. Changes in toolkits must have been related to changes in environmental factors, but such detailed connections have not been fully worked out. The term Mesolithic is generally used for post-Pleistocene, i.e., Holocene, hunting-gathering Stone Age cultures marked by the use of microliths. It is not, however, easy to delineate or identify this phase with precision. Sites such as Patni, in Maharashtra, and Fahinlina, Badadambalina, and Bellilina, in Sri Lanka, have given evidence of microliths in late Pleistocene contexts. Further, microliths are known to have been made and primary sources. Microliths. Microliths range in length from under 1 cm to 5 cm. The tools are mostly made on short parallel-sided blades made of cryptocrystalline silica stone such as quartzite, chert, chalcedony, jasper, and agate. Microliths include miniature versions of some of the Upper Paleolithic tool types such as burins, points, and scrapers. But there is also the introduction of tools in regular geometric shapes such as lunates, crescents, triangles, rhomboids, trapezes, and trapezoids. Microliths are usually classified into geometric and non-geometric types. What was the use of such tiny tools? This question can be answered by supplementing the archaeological data with ethnographic evidence from communities in different parts of the world who still make and use such stone tools in their daily lives. Some microliths may have been used as tools in themselves, but many must have been hafted, singly or in large numbers, onto wooden or bone handles to make composite tools. In some instances, the original hafts have survived. Microliths could have been used to make spearheads, arrowheads, knives, daggers, sickles, and adzes. It is possible that poison was applied to microlithic tips and barbs to add to the lethal effect of the weapons. Microliths were also embedded in a wooden matrix to make sickles for harvesting plants. Sars Sankalia 1964, 1982, 69-77, Misra, 1974. Used well into the historical period. The Mesolithic economy, like the Paleolithic, was still essentially based on hunting and gathering, but some sites have given evidence of the domestication of animals. Mesolithic sites re-ECT different levels of sedentariness. Some seem to have been permanent or semi-permanent settlements, or at least settlements that were repeatedly inhabited over long periods of time. Pottery is absent at most Mesolithic sites, but it occurs at Langnaj in Gujarat and in the Khmer region of Mirzapur, up. One of the features of the Indian Mesolithic phase is the spread of settlements to new ecological niches. For site details, see Alchin and Alchin, 1997, 88-110, Chakrabarti, 1999, 98-110. This is generally seen as a result of an increase in population due to more favorable environmental conditions as well as technological innovations. There is a calibrated range of dates from various Mesolithic sites, example Bhimbatka, 6556 to 6177 BCE, 4895 to 4580 BCE, Bugger, 7416 to 6622 BCE, 4246 to 3991 BCE, Bajer, 5418 to 4936 BCE, 4575 to 4344 BCE, Sarinahurai, 9958 to 9059 BCE, and Pazra, 6377 to 6067 BCE. The transition from a hunting-gathering stage to the beginnings of settled agriculture can be traced at Chopini Mondo in the Bellon Valley, Sharma et.al., 1980. Excavations revealed a 1.55 m thick occupational deposit, divided into 3 periods. The RST was AP Paleolithic, while the second and third were clearly Mesolithic. Period 2 was divided into 2 phases IIA and IIB. Period IIA had non-geometric microliths such as blades, points, scrapers, and borers, mostly made of chert. In period IIB, there were a large number of geometric microliths. The microliths continued into period 3, which was also marked by handmade pottery with cord-impressed patterns, anvils and hammer stones, querns and molars, used for grinding and food processing, and ring stones. There were bones of wild cattle and sheep/goats. Pieces of burnt clay with reed-impressed zions showed that the Mesolithic people of Chopini Mondo lived in wattle and dog huts. The excavations revealed the outlines of 2 round huts belonging to period IIA and VE round huts of period IIB. In period 3, there were remains of 13 round and oval huts, clustered very close to each other. The round huts had an average diameter of 3.3 m, and the oval ones 4.7 times 3.3 m. Outside the huts were 3 hearths and traces of what seemed to be the bases of storage bins made of bamboo and clay. Wild rice is reported from late Mesolithic levels at this site. The 3 excavated sites of Surinahuri, Mahadaha, and Damdama lie very close to each other. Surinahuri, in Pratapgarh district, UP, is located on the banks of a dried oxbow lake which marks an old course of the Gunga. Geometric microliths were found here, along with shells and animal bones, of bison, rhinoceros, stag, sh, and tortoise. Within the habitation area, there were 11 human burials in oblong pits, those of 9 men, 4 women, and a child. The age of the men was estimated to be in the range of 16 to 35 years, and that of the women 15 to 35 years. One of the buried skeletons had an arrow embedded in its ribs. A multiple burial contained the remains of 4 persons. Microlithic tools, animal bones, and shells were placed in graves as grave goods. An analysis of the skeletal material revealed that the dental health of the people was on the whole good, but that some of them suffered from osteoarthritis. The Mesolithic level at Surinahuri has been dated c. 8400 plus or minus 150 BCE by the radiocarbon method. Mahadaha is also on the banks of an oxbow lake. Excavations revealed a 60 cm thick occupational deposit in distinct areas associated with habitation and butchering. The microliths were made of chert, quartz, chalcedony, crystal, and agate, all of which must have been brought over fairly long distances across the river from the Vindhyas. 28 burials of 30 individuals, including 2 instances of a man and woman buried together, were found within the habitation area. The burials were elliptical and their base sloping. The grave goods included microliths, shells, burnt pieces of animal bones, bone arrowheads and rings, and ochre pieces. The bones found in the butchering area included those of wild cattle, hippopotamus, deer, pigs, and turtles. Thousands of animal bones were found in the lake area. The Mesolithic people of Mahadaha were tall. Men were up to 1.90 m and women 1.62 to 1.76 m. Their dental health was good, but many of them suffered from osteoarthritis. Of the 17 males, 7 females, and 3 children identified in the skeletal record, 5 represented persons less than 18 years old, 6 belonged to the 18 to 40 age group, and only 1, a female, represented a person between 40 to 50 years old. These girls provide an idea of average life expectancy. Damdama is situated at the confluence of a small stream belonging to the Sai River system. Within the 1.5 m thick occupational deposit, excavators discovered microliths, bone objects, querns and molars, anvils, and hammerstones. There were hearths, patches of burnt or plaster, charred wild grain, and animal bones. There were 4 multiple animal bones at Mesolithic sites. Bones of wild and domesticated animals have been found at some Mesolithic sites. However, there is considerable difference of opinion among experts when it comes to the identification of animal species. Bajer, Rajasthan. The Mesolithic context here dates to the 5th and 4th millennia BCE. There are differences in opinion about the identification of the animal bones. P. K. Thomas identified domesticated cattle, 15.7% of the identifiable bones in the assemblage, and sheep/goats, 64.4%. It is not always possible to distinguish between sheep and goat bone fragments. The site also yielded bones of wild boar and pig, 3.7%, buffalo, 0.8%, black buck and gazelle, 4.4%, spotted deer, 4.8%, somber, 4.3%, hare, 0.6%, Indian gray mongoose, 0.8%, and Indian fox, 0.5%. Other species include porcupine, rat, tortoise, sh, and frog. Dr. Shah does not mention the occurrence of such domesticated species, but lists river turtle and monitor lizard. Tilwara, Barmer district, Rajasthan. According to V. N. Misra, the late Mesolithic level, its dates are uncertain, gave evidence of wild goat, a canid, jackal or dog, pig, spotted deer, hog deer, mongoose, and domesticated humped cattle. Thomas only reported cattle and goat/sheep from this site. Langnage, North Gujarat. The Mesolithic context in which the animal bones were found was dated 2550 to 2185 BCE. Only wild animals were represented. These include a canid, probably wolf, mongoose, rhinoceros, wild boar, cheetal, hog deer, swamp deer, nilgai, and black buck. The presence of wild buffalo or wild cattle has also been suggested. V. N. Misra suggested that the climate of the area during Mesolithic times must have been arid. However, the presence of the rhinoceros and the possible presence of the water buffalo go against this theory. The rhinoceros is known to prefer large stretches of marshland and grassland. The animal bones at Langnage suggest that the area was covered by a combination of savanna and forest with interspersed wetlands. Kanual, North Gujarat. This site has given evidence of bones of rhinoceros, buffalo, spotted deer, swamp deer, nilgai, and wild boar. Bones of domesticated cattle, sheep, and goats have also been identified. The occurrence of camel bones is interesting and shows contact with people using these animals. Lodeshwar and Rutnupur, North Gujarat. Bones of domesticated sheep, goats, and cattle have been recently reported from these sites. Adamgarh, MP. Bones of domesticated cattle, sheep, goat, pig, and dog have been reported here, along with those of wild animals such as spotted deer, barasingha, somber, porcupine, hare, lizard, and a species of the genus Equus. There are two very different radiocarbon dates for these NDS, one falling in the 6th millennium BCE, the other in the 1st millennium BCE. Due to the uncertain dates and stratigraphy of the NDS, the evidence of early animal domestication at Adamgarh has been questioned. Bhimbatka, MP. This site has given bones of domesticated cattle along with those of wild animals such as barasingha, hog deer, and rhinoceros. It is interesting to note that Mesolithic paintings at this site have representations of Indian humped cattle, zebu, as well as its wild progenitor, Bos namadicus. Sarinahurai, Mahadaha, and Damdama. Up the funnel evidence from these sites is controversial. Kr. Aller identified wild cattle and sheep/goat. According to UC Chattopadhyaya, there is no evidence of sheep or goats, wild or domesticated, at these three sites. Thomas and Joglekar identified over 30 species including cattle, gaur, goat, gazelle, cheetal, somber, barking deer, mouse deer, rhinoceros, wild boar, pygmy hog, hippopotamus, elephant, wolf, jackal, sloth bear, porcupine, rat, and bandicoot. No domesticated animals are represented. Chopini Mondo, up bones of wild cattle and goat/sheep are reported from this site. Sars Chattopadhyaya, 2002. Graves, Subsistence, and Settlement Patterns. Umesh C. Chattopadhyaya has explored the connections between the emergence of formal burials among hunter-gatherers and the subsistence patterns and settlements of the Mesolithic Ganga Valley. His study is based on the funnel remains and burials at Sarinahurai, Mahadaha, and Damdama. An initial study of Sarinahurai suggests that the site was occupied seasonally and that in summer, groups living in the Vindhyan stretches migrated into the Ganga Valley due to water and food scarcity. Excavations at Mahadaha and Damdama led to a questioning of this hypothesis, largely on the basis of the thickness of the occupational deposits and the occurrence of many heavy non-transportable grinding stones. Chattopadhyaya has carried forward this questioning. This area had diverse food resources. The plant remains at Damdama suggest the availability of various types of wild edible plants. The animal bones found at these sites included those of wild animals exploited for food. The subsistence base of the Mesolithic people had a special emphasis on the hunting of swamp deer, Cervus devosli, and hog deer, Axis procenus, and must have been supplemented by an intensive use of aquatic resources such as tortoise and sh. Mahadaha and Damdama yielded teeth of hog deer and swamp deer. As the breeding season of these animals is known, April and July can be identified as the months of birth of the two species respectively. On the basis of the analysis of some of the teeth remains, the age of the animal at the time it was killed and the month in which this happened can be ascertained. This gives us an idea about the months/seasons in which the sites were occupied by humans. Chattopadhyaya's analysis of such teeth remains shows that Mahadaha and Damdama were occupied during summer as well as winter. The presence of a commensal species, one that depends on humans for its food, such as bandicoot rat, Bandicota bengalensis, at these sites is also significant, as this species cannot establish itself at a habitation site unless food is available to it all year round. The evidence of burials at the three sites confirms the above conclusions. All three display similar burial practices. The bodies were buried in shallow rectangular graves, usually in an extended position. Male burials outnumber female burials. There are a few instances of child burials at Mahadaha and Damdama. Differences in grave goods suggest some level of social ranking. At Mahadaha, the cemetery-cum-habitation area revealed 35 pit hearths containing burnt clay, ash, and charred animal bones, which seem to have been associated with funerary rituals. What is most significant for Chattopadhyay's argument is the orientation of the burials. With a few exceptions at Damdama, the graves were broadly aligned west, east or east-west. Archaeological and anthropological evidence suggests that it is likely that they were aligned towards the point of sunrise or sunset at the time of burial. The precise points of the east-west orientation would have varied to some extent in summer and winter. Many of the burials at these sites fall broadly within the calculated range of the annual solar path across the horizon, suggesting that burials took place both in summer and in winter. This too indicates that the sites were occupied all year round. Anthropologists have identified a close relationship between the designation of formal areas for the disposal of the dead and the existence of corporate group rights over critical resources. These rights are based on lineal descent from deceased ancestors. The Mesolithic burials of Mahadaha are suggestive of this sort of situation. But what were the reliable but restricted resources over which these people may have tried to stake their claim through descent? Chattopadhyaya suggests that they consisted of aquatic resources such as tortoise and sh, which have rich nutritional value and are very productive and reliable food resources. The growing population in the Ganga Valley during the Mesolithic phase may have led to competition and con-ICT over these resources. This may have been the impetus for people to come together and function as corporate groups and to stake their claim to territory through burial practices and burial symbolism. Source Chattopadhyaya, 1996. Burials among the 41 human burials. In one of the graves, an ivory pendant was found among the grave goods. Dates for Damdama fall within the early 7th millennium BCE. Recently, domesticated rice has been reported from Mesolithic levels at this site. Rock shelters excavated at Lekakia, in Mirzapur district of southern UP, have yielded blade tools and microliths. There is a clear tendency of tools to become progressively smaller in the upper levels of the deposit. Burials were found, and so was pottery. Baghaikir is another rock shelter site in the same area. This has a pre-ceramic and a ceramic microlithic phase. Two extended burials were identified, the RST belonging to the pre-ceramic phase and the second to the ceramic phase. A 105 SQM section of a Mesolithic ore was excavated at Pesra. Apart from microliths, there was evidence of large and small replaces positioned very close to each other. The thinness of the deposit suggests a short period of Mesolithic occupation. Burbanpur is close to the Damodar River in Burdwan district in West Bengal. Mesolithic stone tools made of quartz, some of chert and chalcedony, were found here. This seems to have been both a habitation and a factory site. A study has shown that the journey to get chalcedony. The general picture of the Mesolithic phase is one of small, mobile bands of people exploiting the resources available in their environment with their microlithic tools. Recent studies have indicated that the reality was far more complex. Gurcharan S. Khanna's study of chalcedony at Bajar in eastern Rajasthan has highlighted how a focus on this one raw material reveals patterns of movement, exchange, and resource procurement. Here are some of the endings. Made of chert and quartz, but some are of chalcedony. Tools made of quartz form about 79% of the total stone tool assemblage, those made of chert about 20% and chalcedony tools about 1%. However, if only the niched tools are considered, the percentages are different. Chert tools represent the greater proportion and quartz tools are much less. The proportion of chalcedony niched tools is variable but not insignificant. This stone was preferred for making smaller blade tools. 2. Chalcedony is a member of a group of cryptocrystalline minerals which includes chert, jasper, opal, flint, agate, and carnelian. Compared to other rocks, Chalcedony has higher water content and a fibrous grain structure. These qualities make it easy to control flaking and to make standardized tools, especially small ones. This is why Mesolithic people may have preferred chalcedony over other stones for making such tools. 3 While chert and quartz are available within walking distance, the chalcedony found in this area is of poor quality. Good quality chalcedony is available in the Deccan Traps, 90 kilometers to the southeast of Bajor. That is probably the area from where the Mesolithic people obtained it. For there could have been another reason for moving southeastwards seasonally. Bajor is located on the eastern side of the Aravalli Hills, which is an intermediate zone as far as rainfall is concerned. The Mesolithic people of Bajor may have moved southeastwards in the dry post-monsoon season in order to end grazing land for their animals. There is evidence of animal domestication at this site. 5 The people of Bajor could have obtained chalcedony from the Deccan Traps either through direct procurement or through exchange with intermediate groups. 6 In the later part of the Mesolithic phase, there is evidence of copper. It is possible that the introduction of copper at this site had to do with the interaction of its people with the farmers and metallurgists of Ahar, a settlement which lay at considerable distance to its south. Sarskunna, 1993. Climate during the Mesolithic phase at Bhimbatka was drier than in the immediately preceding phase, which was more wet and humid. Bajor, in Bhilwara district of eastern Rajasthan, is one of the best documented Mesolithic sites. It is located on a sand dune, about 25 kilometers west of Bhilwara in Rajasthan, close to the Kothari River. The 3 occupational levels represented continuous human occupation over more than 5,000 years. Period I. C. 5000 to 2800 BCE, according to radiocarbon dates, was Mesolithic. Period 2, C. 2800 to 600 BCE, Chalcolithic, and period 3, C. 600 BCE, 200 BCE, gave evidence of iron. Microliths were found in the greatest numbers in period I but continued into the later phases as well. The microliths of period I were mostly made of locally available chert and quartz. Most of them were made on blades and they included a large number of geometric microliths such as triangles and trapezes. Houses paved with stone slabs were found, and in some places, there was evidence of roughly circular arrangements of stone that may have marked the outlines of shelters. Certain stone-paved areas with a large number of animal bones were probably butchering areas. Only one burial was unearthed and there was no D-night evidence of grave goods. Other discoveries included ring stones, perhaps used as hammer stones to make microliths, pieces of red ochre, querns, and rubbing stones, for grinding food. Bones of wild animals included those of wild cattle, 2 kinds of deer, pigs, jackals, rats, monitor lizards, turtles, and bones of domesticated sheep/goats and cattle were also reported. There is a possibility that small bits of pottery found at the site may belong to the Mesolithic phase. Microliths have been found in the valleys of the Tapi, Nirmada, Mahi, and Sabarmati. One of the important sites is Langnaj. The occupational deposit here was divided into 3 periods. Period I was Mesolithic and yielded microliths, human burials, bones of wild animals, and some pots herds. Adamgarh Hill near Hoshangabad has already been mentioned among the Paleolithic sites of central India. Its upper layers represented a Mesolithic level, which in turn made way for a Neolithic, Chalcolithic one. Shells found between 15 to 21 centimeters from the top of the Mesolithic deposit were dated by the radiocarbon method to c. 5500 BCE, so the Mesolithic level belongs at least to the 6th millennium BCE. Thousands of microliths were found here, mostly made of chert, chalcedony, jasper, and agate, raw materials which are available in the riverbed of the Nirmada about 2 kilometers away. Geometric microliths, triangles and trapezes, were very common. Mace heads or ring stones and hammer stones were also found. The wild animal bones comprised those of the hare, lizard, various kinds of deer, horse, and porcupine. Bones of domesticated cattle, sheep, goat, dog, and pig have also been reported, but this evidence has been questioned. This site has given evidence of pottery at Mesolithic levels. Bugger II in the Sun Valley has already been mentioned in the discussion of the Paleolithic sites of central India. This site also has a Mesolithic phase. The tools are of chert and chalcedony, and geometric microliths occur. Fragments of grinding stones, one hammer stone, and pieces of red ochre were found. There were very few niched stone tools, and as much as 96.7% of the total Mesolithic lithic material that was excavated consisted of waste material of stone tool working. This suggests that the tools were made here and taken away to other places. The location of VE or 6 large shelters can be identified by a series of post holes. 3 hoof prints of a somber deer were preserved in the excavated deposit. Bhimbatka has also already been mentioned in the section on Paleolithic sites. The site shows a gradual reduction in the size of tools. Mesolithic tools include blades and geometric microliths like triangles, trapezes, and crescents. Quartz was used a great deal in the Paleolithic stage, but in the Mesolithic phase there was a shift to chalcedony. Bhimbatka is famous for its Mesolithic paintings, which will be discussed further on. In peninsular India, Microlithic sites found in the vicinity of Mumbai seem to represent coastal Mesolithic communities who exploited marine resources for food. Microliths have been found in other parts of Maharashtra as well. Further south, the microliths are mostly made out of milky quartz. They have been found at Jalahali and Kubanhalli near Bangalore in Karnataka, in Goa, and at Nagarjunakonda, in southern AP, and Renagunta, in Chittor district, AP. Microliths occur at many places along the east coast of India and seem to mark camps of Mesolithic Shing communities. South of Chennai, tiny stone tools, mostly of quartz and chert, have been found on old sand dunes known as terrace. On the Visakhapatnam coast, stone tablets and ring stones have been found at sites such as Chandrampalam, Paradesipalam, and Rishikonda. Similar stones are used today by local Sherman in the area as net sinkers. Apart from the coastal areas, rock shelters, at hilltops, river valleys, and lakesides were also inhabited during the Mesolithic phase. The evidence from Mesolithic sites from different parts of the subcontinent suggests movement and interaction among communities. Factory sites located at sources of raw materials must have been meeting grounds for different groups. The fact that Mesolithic tools found north and south of the Ganga are made of the same kinds of stone indicates that either the raw materials or the tools themselves were moved across the river. The Mesolithic people of Sarinahurai, Damdama, and Mahadaha would have had to travel over 75 kilometers to reach the stone resources of the Vindhyas. Clearly, the communities living in the northern alluvial plain and the hill people of the northern fringes of the Vindhyas must have been interacting with each other. In later times, Mesolithic communities must have interacted with early agriculturists who lived in their neighborhood. There are many instances of temporary Mesolithic campsites in various parts of the subcontinent, but sites such as Sarinahurai, Damdama, Mahadaha, and Shopani Mondo were inhabited continuously. This can be inferred from the nature of the archaeological evidence and also certain more specialized studies of the funnel material. The evidence from several sites of formal, ceremonial burials, with the bodies usually laid out in a west-east direction, sometimes the other way around, with grave goods suggests rituals associated with death. The presence of grave goods is often taken as an indication of some sort of belief in afterlife. This may well be so, but there is ethnographic evidence of societies in which certain belongings of the deceased are considered to bring bad luck to the living, and these are therefore buried along with the body. Instances of jewelry found on the body suggest a custom of adorning the body before burial, and may indicate high-rank individuals within the community. The magnificence of Mesolithic art. There are very few examples of portable Mesolithic art. A chert core engraved with an interesting geometric design was found at Chandravati in Rajasthan. It is assumed to be Mesolithic because lots of microliths have been found at the site. A few engraved bone objects have been discovered at sites such as Bhimbatka. A human tooth with faint geometric marks on it was found in a jaw fragment along with some other teeth, and is currently kept at Deccan College, Pune. The RST rock paintings in India, and in fact anywhere in the world, were discovered by A.C.L. Carlile, an assistant surveyor with the Archaeological Survey of India in 1867–68 at Sahajiyat in the Kaimur Hills in the present Mirzapur district, up. Today, over 150 Mesolithic rock art sites have been found in various parts of the subcontinent, and central India has an especially rich concentration of sites. The paintings are an important source of information regarding the lives of Mesolithic communities and show striking thematic similarities across the country. In 1957, The archaeologist V.S. Wakankar noticed the Bhimbatka rocks out of a train window while traveling from Bhopal to Itarsi and got off at the nearest railway station to explore. This is how one of the most magnificent rock art sites in the world was discovered. Bhimbatka is one of 7 hills marked by a very picturesque natural environment. There are 642 rock shelters here, nearly 400 of which have paintings, engravings, and bruisings. Their style, theme, and worn state indicate that they belong to old times. Mesolithic paintings have also been found at other sites in Madhya Pradesh such as Karwar, Jaira, Kathasha, and Lakajor. The Bhimbatka paintings have been studied by V.S. Wakankar, Yashodhar Mathpal, 1974, and Erwin Neumayer, 1983, and the results of their research illuminate many aspects of the lives of the painters. Mathpal identified 3 main phases of the rock paintings, with further subphases within these. The RSTVE subphases are Mesolithic, the 6th is transitional, and the last 3 belong to the historical period. 16 colors or shades can be identified, with white and light red used most often. The colors were made from minerals which were ground and then mixed with water or some other substance like animal fat, marrow, or egg white. The red was made out of iron oxide, Jeru. White from limestone, and green may have been made from green chalcedony. Some paintings are monochrome, in one color, while others are polychrome, in more than one color. The handles of brushes must have been made from twigs, and the brush itself out of squirrel tail, animal fur, or simil, silk cotton. As at most Mesolithic rock art sites, animals dominate the scenes at Bhimbatka. 29 species of animals are depicted, including the cheetal. This occurs most of 10, leopard, tiger, panther, elephant, rhinoceros, antelope, deer, and squirrel. Different kinds of birds, lizards, frogs, crabs, scorpions, and small centipedes also make an appearance. Although the Bhimbatka hillsides are still home to many animals, the elephants, rhinoceroses, lions, wild buffalo, gaur, and black buck depicted in the Mesolithic paintings have disappeared. It is interesting to note that no snakes are depicted in Indian Mesolithic paintings, here or elsewhere. In Mesolithic art at Bhimbatka and elsewhere, animals are represented on their own or as part of hunting scenes. Hunters hunt singly or in groups, sometimes wearing masks and headdresses crowned with antlers and horns. They are adorned with ornaments such as necklaces, bangles, wristbands, elbow bands, and knee bands with tassels. Some are unarmed, others carry sticks, spears, bows and arrows, or slings. The hunters are sometimes accompanied by dogs. There are scenes showing traps and snares, others of animals running after hunters. While some of the animal gurs are rather abstract, many of them are very realistic. Animals are sometimes shown in outline, in other instances their bodies are decorated with designs. A few paintings are in the X-ray style, showing the inner organs, including foetuses in the womb of female animals. Apart from hunting scenes, animals appear in more peaceful, sympathetic scenes such as those depicting pregnant animals, a panther or tiger with cubs, stag, and cheetal running after a fawn, grazing buffaloes, rabbits hopping, and monkeys leaping about. There is a lot of movement in the scenes. There are also fantastic animals. The famous Bhimbatka boar has the body of a boar, but a snout like a rhinoceros, the underlip of an elephant, and the horns of a buffalo. Mesolithic paintings at Bhimbatka and other sites also depict men and women, young and old. Male gurs often look like matchsticks, women are sometimes given fuller forms. Some men wear loincloths, probably made of leaves, animal skin, or pieces of tree bark. Men wear their hair loose, women braided. Some gurs are broad and decorated with geometric designs, and from their attitude seem to represent men of authority. Masked dancers, referred to by prehistorians as dancing sorcerers, may represent ritual specialists. Hand, and Enger prints are also found, similar to those that people make on their houses these days on auspicious occasions. The Bhimbatka paintings re-ect a division of labor on the basis of gender. Men hunt and women are shown gathering and preparing food, for instance grinding food on querns. It is difficult to identify what sort of vegetable food was being processed. Basket-like containers must have been used to store food, but no pottery is depicted. Dry gourds and leather bags may have been used to hold water. There are scenes of people collecting fruit and honey. Some scenes depict sexual activity, others show people dancing. The dancers convey a sense of rhythmic movement, occasionally they lose their balance and fall. In Europe, most prehistoric paintings tend to be located in dark, relatively inaccessible parts of the caves, but those in Indian rock shelters are usually in well-lit areas, easily seen. The best paintings were not, however, made in shelters that were living spaces. Some of the big paintings on high surfaces would have required scaffolding and the cooperation of many people. Such paintings, and those made in layers, suggest some kind of ritualistic significance. Prehistoric rock art sites have been found at many other places in India as well. In eastern India, over 55 rock shelters with rock art have been identified in the western districts of Orissa, especially in the Sundargarh and Sambalpur districts. Microliths found in some of the rock shelters have confirmed the fact that there was Mesolithic occupation in the area. The richest area for rock paintings are the 12 rock shelters of the Lakamoda group in the reserve forests of Chengapahad and Garjan Pahud. Excavations in one of these rock shelters revealed a cultural sequence from the Mesolithic to the Chalcolithic. An interesting feature of the rock art of Orissa is the coexistence of paintings and engravings in the same shelter. Also, the art is mostly non-gurative, with an emphasis on abstract patterns and decorative designs, both geometric and non-geometric. Animals occur infrequently and humans are even rarer. Kerala too has many rock art sites with paintings and carvings. One of the oldest is the cave known as Eziuthuguha, situated in the midst of a dense sandalwood forest in Idukki district. In the earliest stage of rock art in this area, animals were depicted, but no humans. One problem is that although some of the paintings have been assigned to the late Mesolithic phase, no Mesolithic tools have been found so far in any of the Kerala rock shelters. Why did prehistoric people make such paintings? Probably for many different reasons: to express their creative urges, to decorate their homes, or to tell a story in pictures. Some scenes may have been picture stories of memorable events in their lives. Others may have been connected with rituals connected with hunting or fertility. It is impossible to say whether the paintings were made by men or women, or both. Apart from the scenes of animals and people, there are a few more enigmatic paintings. A very interesting, rather abstract painting has been found in a rock shelter at Jaira, MP. Perhaps it reacts a view of the world consisting of air, earth, and re. But it is possible that it means something completely different. The Mesolithic artist who painted it would have known for sure, but since he/she is not around to tell us, we have to use our imagination to try to unravel its meaning. Conclusions. Prehistory represents the longest part of the human past, and is associated with the emergence of anatomically modern humans and important developments in stone tool technology and subsistence strategies. Paleo-environmental studies form the essential background for the reconstruction of the life ways of prehistoric people. The evidence of the lower, middle, and upper Paleolithic phases in the subcontinent is gradually increasing, but still largely consists of stone tools. Mesolithic communities fanned out into new ecological niches, and the evidence of rock art provides valuable information about their lives and aesthetic sensibilities. Paleolithic and Mesolithic people obtained their food through hunting and gathering. However, the animal bones found at some Mesolithic sites indicate that the beginnings of animal domestication can be traced to this phase. The major transition from hunting-gathering to food production based on the domestication of plants and animals is associated with the next cultural stage, the Neolithic.